Hi. In this video, I'm going to look at a few errors that students make when they're writing down their solutions to linear equations. And the errors I'm going to look at are kind of subtle things. They're not kids or students who really don't understand. They're students who just have made little mistakes in the way that they've written things, or just who haven't written sort of the nicest algebraic solutions. So I'll show you how to fix them. Okay, so the example we're going to use, and I'll go through first and solve it, is to solve 5x subtract 4 equals 16. I'll solve it sort of fairly quickly here. So if we've got 5x and we're subtracting 4, and that gives us 16, we want to do the opposite to isolate our x. So we have 5x subtract 4 equals 16. We're going to add 4 to each side. We'll do that in another color, because it helps me see that I've done it there on both sides. And then that gives us on the left just 5x. On the right, that's 20. And I'll copy that again, and I'll write our next operation again in another color. We're going to divide both sides by 5. And that gives us on the left x, and on the right 4. So x equals 4. All right. Now let's check this equation. First of all, copy down the very original equation, not some sort of later version, just in case you made a mistake in the first step maybe. So we'll write 5x subtract 4 equals 16. And as you do this, I think it's, from a logical point of view, really important to show that you're asking the question. So is 5 times, we're going to replace our x with 4, subtract 4, is that equal to 16, question mark? And then we're going to simplify each side. The right side's already simplified, so we don't need to do any work there. So 5 times 4 is 20, subtract 4 equal to 16. Of course, a lot of people could just quickly do that in their head, but I think it's important to show what you're doing. 20 subtract 4 is 16, and it only takes a second. Is 16 equal to 16? Of course. Yes. So that tells us, because the left side was equal to the right side when we substituted our value for the variable, that tells us that x equals 4, that was the value we had. It's a solution to the equation 5x subtract 4 equals 16, because that's what it means to be a solution. Okay, so that I hope, if that isn't relatively straightforward for you, it's probably looking at these examples won't be super helpful. You might want to go back and do a little bit more review first. All right, so these examples I've chosen, they're all students who know what they're doing, and they're all fairly common errors that I see. So I've taken, so they're sort of composite students. It's not a particular student who's made these errors, but they're errors that we see over and over in different equations. So the first one, actually, and I use the word error, the first one is really the only one that is an error. The first one really is wrong, and then we'll talk about the degrees of rightness and wrongness of the other ones. So the student copied the equation here, and then I think the student thinks, I want to get rid of the 4, so what they do is subtract 4 on both sides. That gave them 5x is 12, and then they divided both sides by 5. The way that the student went wrong here is that if you subtract 4 and you subtract 4 again, that's the same as subtracting 8, and they were thinking that that was going to make this go away or be equal to 0. Okay, so what they should have done here is they should have added 4 like we did, right? And then that would give them 20, and that was 20 as well. And 20 divided by 5 is 4. So for this student, maybe the advice I'd give them is to use opposites. If you're trying to get rid of a number. So don't just think like, I have a 4, I want to get rid of it, I'll subtract. If we were subtracting 4 before, what you want to do is add 4. Okay, so our next student here, there's 2 things I want to address here. And you can tell right away the student got the right answer. So this is likely very, very good work happening here. So they copied down the equation, and then they added 4 to both sides. The one thing I'd just like to, this is not wrong, but I would really like to see that you've copied the equation first, and I'd like to see that you're adding 4 on both sides. Maybe I'll underline that in red. I'd like to see this here and this here. And I think it's good as well for the people doing it to see it on both sides, to sort of confirm that you've done it, you haven't forgotten about one side, and so on. So this is not wrong, but I think adding this detail is good and valuable. And then we get down to 5x equals 20. And then the student is thinking 20 divided by 5 equals 4. So this is absolutely correct. I would rather actually not see this. Or if you'd like to show it, because maybe especially if the numbers were bigger, you might just be thinking it and you might want to write it down. I'd rather maybe see it off in a margin somewhere, 20 divided by 5 equals 4, if you want to write it. I don't want it, what we do when we're solving algebraically is we write a series of equations that are equivalent to each other. That means they have the same solution. And here, we don't have any variable at all anymore. So let's just get rid of that right there. Write it on the side if you want. And then, so first copy the equation down, 5x equals 20, and then write the operation that you're doing on both sides. That we're dividing both sides by 5. All right? So nothing that this student wrote was wrong, but this, I think, is a stronger algebraic solution now. So if we're going to give advice to this student, I would say, first of all, copy the equation. I'm going to write EQN for equation. Copy the equation first. And then as a second step, do the operation to both sides. And that would have actually improved the student solution in both of these places. So copy what you have first, and then do the equation. Here it was the adding 4. And here if you copy that and then divide by 5, that gives you a stronger solution. All right? So this first student here, these are fictitious students, of course. This student made an error. The student didn't make an error, but if they added this, if they wrote it like this, it would be a better solution. All right, we'll go over here now. Now this student, you get to the end here and you think, well, they've got x equals 4. This is probably a very good solution. And it is a very good solution. There is one actual error in it, okay? So unlike this one where it just could be sort of improved, this one actually has an error. There's a mathematical lie in here, by accident, of course. And it was something that the student knew that they were doing, they just didn't get written down. So they started off by copying the operation, 5x subtract 4 equals 16, so this is good. And then, if we follow this student's advice, copy the equation first, 5x subtract 4 equals 16, that's good. And then actually here's where you can spot what happened. They added 4 to that side, but they didn't write it down here. So we need to write that there. Now, this student actually knew that they knew exactly what they were doing, and the next line is correct. Right? From there on, the solution is right. But it's important from not if your only goal is to get the answer. You don't need to worry about these kinds of details. But if you're trying to write a strong algebraic solution, it really is important to keep the two sides the same and do the operations exactly the same time to both sides. So let's say for this student, let's get myself a little extra line of space here. So, the suggestion would be write the new operation on both sides on the same line. So it's happening at the same time. In the second step here, we're adding 4, so write that down. Another hint to the student, certainly not mathematically necessary, but just sort of useful, this is why I use another color, so I can make sure I did that. And it's really obvious if they're both there in purple. So if the student has another color, that could be helpful for them. Okay, the last sort of frequent mix-up I want to look at actually has to do with the checking. And I'll show you what it is here. So this is a student who knows a lot. So the student, first of all, copied the equation down, and then the student knows that we're just checking, is this equal? So then they've written it down, is this equal to that, with a question mark. It's beautiful. And then where my solution here got sort of simpler and simpler, it looks like theirs is getting more and more complex. But it is still a series of equivalent equations here, and they've come out to two values that are equal, and they know to say that this is a solution. Here's what's going on with this person's work here. This fictitious student has mixed up sort of solving and checking, and has a little bit done them both at the same time. This work is not wrong, but it's a lot more work than necessary, and I really wouldn't suggest checking an equation like this. Because if you had made a mistake, say you happen to be this student this day, if you made a mistake when you're solving the equation, you would likely do exactly the same mistake again. What they've done is exactly the correct steps here. This person has added 4 to both sides of the equation, and then they've divided both sides by 5. Right? So if you made a mistake the first time, you'd probably make the same mistake again. So for this student here, I won't write it down, but what I'd really suggest that a student like this do is to simplify each side independently. So just copy everything down like you have, and then just write down what is the left side equal to. Simplify it a little bit. 5 times 4 is 20, so write that down. 20 to subtract 4, like this. And then do the subtraction and write that down underneath. And then on the other side, do the other side independently. And there's nothing to do here. We're just subtracting 16 each time. So you can just keep writing that underneath. So when you're checking, treat each side as independent. Okay? All right. So good luck to all of you. Thanks.